Righto. Okay, so with this tutorial, I'm going for something a little bit different in that already done the download. I'm not going to be completely building this one up from scratch during the video, purely because my time, sometimes I get pulled away from the screen and it gets a bit tough to build something that takes, 20 minutes, half an hour without getting interrupted. So this model is already built and is in the download link in the description. If you have any issues getting this model, let us know. Rather than me building it from scratch, I'm just going to make some minor changes to it as we go through, and I show you the different parts that make this up. So this one is all about creating a margin rank. So there's a case built into this, and it's at the moment it's purely colored by whether or not it's got a positive or a negative net margin. There's a few other things that we could choose to flag as well. Once you can build this up, you can start to get a little bit creative in terms of whether or not it's worth positive, negative. There's a variety of different things you can do. And this one's going to be pretty simple, but it's just to show you the framework of how you can get started. So to start with, I'm just going to show you that we've got one particular margin rank. It's going to be a double field called cumulative margin. In the format string, one of the suggestions I would have is right now it's set to be purely a number, just to provide some clarity. What you might want to do is put a dollar symbol in front of it. That will just change the way that it appears in the table. Might help if I put the dollar symbol in the right place, which is at the front of that, not at the end, which is why I don't do these things on the fly. Put a dollar there. You can see the preview. That's a little bit better. Okay, so dollar symbols in front, and the aggregation is set to maximum, so you can see the best possible margin is in my earliest strip, which is generally the case, and you can set this up however you like. Now, in terms of once you've got that field set up, the next place we're going to go to is parameters, and this is where we're going to have a look at a couple of things that are a slight expansion on what has already been shown in previous tutorials, but there's not really all that much different. So what we've got in the settings for this parameter is, rather than there being one range that builds up how we look it up, what we're going to do now is we're looking it up based on the material. And in this simple example, we're just doing it based on waste and coal, and we're just setting up like a fixed cost and a fixed revenue. You can get into more creativity once you can get something simpler working. But what we have is, in addition to the range, which is how we're looking up the input node, we're also adding the material type as a lookup so that we can have a different lookup for waste and coal, right? So I've also ticked on an option which I haven't previously shown you, which is called a limited list. So the purpose of a limited list is so that once you've built the model, you as the builder will understand how it works. But the users who are going to be using it potentially do not. And a limited list is one way of you making sure that the user doesn't pick things that you haven't anticipated. So you unlock the table to go and make an edit, and you start to type in the word overburden, right? It won't let you make that change. It'll say that there's a limited list, but there's not part of the limited list. So it forces you to go back to the drop down and pick something that is in the list. At least it's a protection against people using it in a way that you haven't prepared for, which is always a helpful thing. So we've got a limited list set on the material type, and the list, you just type in the things that you want to be able to use in the limited list. For this model, it's going to match the materials on the data flow. And then down in the attributes, we have a cost, a revenue, and an identifier field that matches them. And what I mean by that in this example is it if it's a cost per, is it volume or tons or something else? In this model, it's only set up to read volumes, volume or tons as the multiplier, but potentially drill costs, you want to multiply by meters, blast costs, you got other things. You can extend upon this. So we've got cost, revenue. Both of those have a format string with some dollar symbols in them to help make it a little bit more clear. If you need more detail than this, the purpose of this is to just show you the basics. If you wanted to break out your costs, have multiple costs, multiple revenues, etc., there are ways to do it. Once again, once you've built this up, you can use it however you like, and you can extend it. So we've got waste, and waste I'm going to multiply. My unit costs are going to be based on volume, and then I've got coal, but my unit costs and revenues are based on tons. for the purposes of making, I didn't realize this until I'd done things, the purpose of making it a little easier to read the costs and revenues, I'm just going to change my coal to the cost of mining per ton to be a little lower. It just makes it a little bit easier to read the numbers that come out on the data flow. And then if we, once you've got this set up, then you're good to go. So this is the parameters side. Once again, you can add complexity to this later on. In terms of how the data flow is set up, just like all the other data flows we've done, we've got a single input block, process block, and output block. Similar to the previous tutorial, we have got a waste and a coal material. And really the only additional difference is we've got quite a few more value fields here. So we're tracking volume, tons, cost, revenue, and cumulative margin. The first two, we're going to read off of the input node, off of the unit. And the other ones, cost and revenue, are going to come off of our parameters table. And the cumulative margin is going to come from the cost and the revenue, but also then an accumulation over the length of a block. So in terms of the grouping expression for this one, we haven't talked much about grouping expressions, but if you've done previous Spry work, you should have a basic feel for it, which is that we're going to do this on a per block level. So we're going to combine, if you share a pit, strip, and block, then you form part of each group, and we're going to accumulate as we go down the block the costs and the revenue. We're clearing the margin rank field, which I've done by selecting this folder. You can also select it over on here. So we're making sure that each time we run it, we get a fresh set of numbers. I've also got waste and coal as my material types. One of the things that can be helpful to help you differentiate them is to set them to some slightly different colors, just so they're a little bit clearer to see when we look at the preview. So I'm going to make that small change here. Value fields, cumulative margin is the only one I'm going to change. The way that it appears on the screen right now is it doesn't show you the comma for the 1,000 separator. So we're going to put that in, and we're going to take out the decimal places, because once you get into the thousands of dollars, you're not caring as much about the cents, and we'll put a dollar symbol in front. So we'll make the cumulative margin appear a little bit differently to the unit cost and unit revenue. Now these actually, now that I remember it, these are actually also on a per, like these are after multiplying by volume and tons in this example, so they can all be set to this format string. And then we don't have any new identifier fields, just the defaults. So it's volume and tons, which are going to be used to multiply by our various revenues and costs. And then there's cumulative margin to store the accumulation. So that's what the input block looks like. Reasonably simple, just filtering into waste if you've got waste volume, and filtering into coal if you've got coal tons. The processing block is broken up into 3 separate sections. It's done this way not because you have to. You could easily summarize it into a single snippet. It's more just to break out the processes. I like, especially for something that's meant to be human readable, to break out things as much as possible into different snippets rather than combining things together. Just makes it easier to troubleshoot. What we've got in the parameters section shouldn't be anything new if you've done the parameters already, but what we're looking at here is some code that iterates over each unit in the units group, where we double check that we've got an input node, and this is just a safety check. We double check that we've got a parameter. Now with the parameter, now that we've got 2 things to look at in the parameter, now that my intelligent path completion is working, parameters dot, what you can see when you go to the get parameter function is it tells you when you open the bracket up what it wants. So it's looking for the material string and the node range, and those names are coming from the material and range. So that's the name of this, even though it's lowercase, the name of this is what drives the path completion assistant, or the intelligent, the IntelliSense down here, code complete. So that material, so it's asking you for the material and the input node. So the material, the way that we read that is we grab the unit's materials name. So when we set text, we do unit.material text. That's the setter. The getter, and if you don't know what that means, you probably need to do a little bit of C#, but the getter for the string is unit.material.name. So that's what gives us whether it's waste or coal. So that's how we look up for each unit whether or not we're meant to be getting waste or coal. And then if we look back at the view here, and we'll drag the material into this for the time being, you can see that when we've got coal, we get a combination of cost and revenue, but when we've got waste, because we don't have any in our parameters, we just have costs. So this is the first part of 3, which is to assign from the parameters the costs. So what we're doing here, the only other new thing, let's get rid of that save prompt. The other thing that we're doing is, so we look the parameter up, we read which field we want to multiply by, as in unit cost, so we're multiplying by volume or tons in this example. So once we get this string, which is this identifier field to match part, we can then look up the value by going unit.value. So previously we've assigned and read various values by just selecting them by the intelligent path completion. So, to get its cumulative margin, you just look for unit.cumulative margin. If you want to look it up based on a string, you can go to value and then go square brackets. And one of the options to look it up is the name of the field. So to be clear, this identifier field to match is looking up this field here. It's looking up the word volume. And because in my data flow, I have a value field called volume, then it's reading that field. So it reads that volume field, and we multiply the cost by that value field, we multiply the revenue by that value field, and then that's how we get the cost and the revenue component for each unit in the data flow. Part 2 of 3 is just to make sure that we've got everything sorted how we want to have it sorted. Now, by default in this model it would be the same, but it's always a good idea to assume that your data is not sorted the way that you absolutely want it to be sorted. Plus it lets you make changes to it. So in this example, what we're doing is we're ordering by seam and by bench. So we order by seam first, so first seam to last seam, and then within each seam, we're sorting by bench. If for some reason you are mining to the bench and not the seam, you would change this around and say firstly order by bench and then order by seam. And what you will see is when we have an example like here, where at the 95D comes before the waste 100E, is we're going to sort by bench first. We're going to get a slight change when we hit recalculate so that the coal from E actually sits above the D from waste. So that's just depending on the methodology that you're mining to. And this is an example where potentially what you want to do is set up a parameter for if you've got an area that goes by bench, an area that goes by seam, and you want to split them out, you might want to create parameters that changes the way that you sort your blocks. So that's part 2 of 3, making sure everything's sorted the way we want to have it sorted. And then the third one is pretty easy, which is just to accumulate the margin, which is we start with 0, we iterate through each unit, and then what we do with each unit is we add the revenue, we subtract the cost, and then we write to the cumulative margin that value that is getting tracked. And so for every block we reset at 0, but then what we're doing is we're going through them in their sorted order and adding to the margin. So if we look at the cumulative margin now, which we'll add, you'll see that until we hit coal, we're building up more and more and more negative. And then once we hit the coal, we pull ourselves towards the positive. Till right at the bottom, you would expect that the highest revenue sits at the bottom, but this is an example where you can start to use your creativity and work out if your highest revenue is at the bottom or if it's at different seams. That's the kind of stuff that I'll leave you to, but this is how you can develop these numbers with a data flow. And so the final part of this model is to write those numbers back to the table. Very, very simple. We're setting the input node and we are filtering to the margin rank just to make it easier to read, and then we are writing the unit's cumulative margin back to the record. Now, one of the things that will happen here is that if you have both waste and coal in a record, if we have a look at an individual record like the 100 for D, so let's go to D100. I just want to talk about how aggregation works and why it's important to have aggregation set. So you'll see here that if I select this cell in the output window, I can see two margins on the block. I can see a waste and a coal. Now, the value that's actually getting written, you can see in the preview, is this number here, the 1723603. It's the same as the 1723. I'm just realizing I can't select this now, but it's the same as the coals record. Now that's because for this example, I have set the aggregation for cumulative margin to be maximum. So if there's more than one possible value from that unit, it's going to pick the highest number, as in greater than 0, not the least or the most negative number. So even though I've got two numbers here, I'm picking this number. You just have to be careful with aggregation in these kinds of worlds, because you want to make sure that you're writing the correct number. So if you had set that to sum, which is oftentimes what sort of the default position of people is that what you'd actually end up with for that record, and I'm just realizing that the preview hasn't updated correctly, but we'll step away from it and come back, and that will force it to recalculate. But that 100 is now coming out at a much greater negative number, which is not what it should be doing. It should be coming out at a number that was in that negative 1,700,000 or whatever it was. So you have to be cautious about your aggregation when writing results. As soon as you go into material splits, how do you deal with a number that is on more than one unit, because they're both competing for that. They're both going back into the same node. So which number should you pick? Should it be summed? Should it be averaged? Or should you have done something beforehand to make sure that the numbers got calculated correctly? So in this example, setting maximum is fine. And then the final little piece of the puzzle here was setting up the colors. So there has been a change to my calculation. The solids don't know that. So if you do make changes to your cumulative margin, you want to hit the refresh colors button, which should... It's just happening so fast that it's not actually looking like it's updating. But that will update your colors. So you make a change to your parameters. I'd help if I ran my data flow. That's probably what it was. I was expecting to see a slight difference. So run the data flow, back to your animation, recalculate. Very slight change. But what you can start to do is play around with your parameters and see the impact. So if I make my waste significantly more expensive, rerun the data flow, reload the solids, you can start to see in this model whether or not, and I haven't tested this value before, but you can see in terms of where things are no longer financially sound, you can start to play around with those numbers. So anyway, that's the basis of how you can do a really simple margin rank. Obviously you can get more complicated than that. As I said, the model link is in the description. If you have questions about how that works, let us know. And I hope that adds some value, and more tutorials coming soon.